This is just a review for writing the linear equation given three different cases or three scenarios covered in Chapter 5. Case number 1 was covered in Chapter 5, Section 1, where you're given the slope and the intercept, and you simply have to substitute. Chapter 5, Section 2, you were given the point and the slope, where you had to find the y-intercept and then substitute the values into slope-intercept form. The third case, which we're going to review today, is when you're given 2 points, x1 and y1 from the first point, and x2 and y2 from the second point. Remember, the first step is to calculate the slope using the slope formula. Think of m as your mountain slope. Just remember, you can also find slope by plotting the points on a graph and counting the rise over the run. If you use this method, just remember the rise is positive if you're going up to the next point, or negative if you're falling down to the next point. If you choose to use the formula, which is more practical to use if the number values are greater, remember it's the difference of the y values, y2 minus y1. Those little numbers, the subscript of x2 and x1, are not exponents. They're just telling you the x from the second point, subtract the x from the first point. After you've found their difference of y's and the difference of x's, you divide. Sometimes you can simplify slope and sometimes you can't, and you'll be asked to leave it as a fraction. Second step is to find the y-intercept. Do you remember where that's located? Great, it's where x equals 0. It's where the line crosses the y-axis. We call that the intersection of the line and the y-axis. Just like an interception in a football game, the y-intercept intercepts the y-axis. The last step is to substitute the m, known as the slope, and the b, the y-intercept, into the equation. So given the first example, 2, -3, and 3, 1. Notice I'm taking the difference of the y's, 1 minus a -3, and now the difference of the x's, 3 minus 2. There's my fraction bar to tell me to divide. Before I can divide, you have to remember 2 negatives together consecutively make a positive. So my 1 minus -3 becomes 1 plus 3, which we can simplify to 4. The sum is 4 in the numerator, and the difference, 3 minus 2, is 1 in the denominator. 4 divided by 1 equals 4. We have a slope of 4. Now we're going to find the y-intercept. In order to do that, we need to use our slope-intercept form. Y equals mx plus b. In order to solve for the y-intercept, you have to choose one of the points. Notice the point that was chosen for this example was 3, 1. What quadrant is 3, 1 in? Do you remember? Well, the x and y values are positive. Must be quadrant 1, because quadrant 1 is to the right and up, just like the point, 3, right, up, 1. Notice I had to choose one of the given points. I couldn't randomly choose values because I need to come up with the equation that contains both points that are given. Notice the 1 goes in for y, the 3 goes in for x, and finally the 4 goes in for slope. The only thing left is to find the y-intercept, also known as the variable b. Well, 4 times 3 makes, you guessed it, 12. So now 1 equals 12 plus b. How did I know that 4 times 3 was 12? That I had to multiply? Remember, any two letters together, just like m and x, means multiplication. To solve for b, I have to get rid of the 12. Since 12 is attached by addition, I subtract 12 from both sides. That's where the negative 11 came from. 1 minus 12 is negative 11. Finally, my last step is to substitute. If I'm going to substitute, make sure you substitute correctly. I have to make sure that my slope is 4 and my y-intercept is negative 11. This is where we often make a mistake. Sometimes we put the wrong value into the wrong place. Just remember the acronym SIS, slope, intercept, substitute. Notice 4 goes on the first line and negative 11 will go on the second line. But I can simplify it because 4x plus negative 11 can also be written as 4x minus 11. Right there, my final answer. So let's try another example. Given two different points. What's that first step again? Oh yes, the slope. Difference of the y's and difference of the x's. Rise over run. Remember us drawing in chapter 4 our right triangles? Counting how many up and how many over for the rise and the run? Notice I'm taking the difference of the y's, 5 minus 2. So I start with the last value minus the second value, and I get a difference of 3. 1 minus 0 is 1. I can simplify. Instead of using 3 over 1, I can simplify it to just 3. In order to find the intercept, step 2, I have to substitute values. In order to do so, I have to pick between the 2 points. It may be tempting to use 0, 2. It may be tempting to use 1, 5, but you're going to have to choose. Since I chose 1, 5, 1 will go in for my x, and 5 will go in for my y. Just remember, coordinates are written as an ordered pair, x before y, just like in the alphabet. You got to kind of know your ABCs. Notice I put in 5 for y and 1 in place of x. But I also have a slope from my first step of 3. Remember what I said about m and x together? That means multiplication. So I'm going to have to multiply the 3 and the 1. 3 times 1, don't tell me it's 4. Any number times 1 is itself. So 3 times 1 is 3 plus b. Just bring it down. How do I get rid of the 3? If it's positive 3, the opposite is negative 3. The 3 minus 3 will cancel out. So I'm going to cross them off. 5 minus 3? Yeah, that makes 2. My y-intercept is 2. So my final step is to substitute. Notice I start with my y equals mx plus b, and I'm going to fill in my m, and I'm going to fill in my b. So m goes on the first line. My slope was, you guessed it, 3. And my y-intercept is 2. Y equals 3x plus 2. There's my equation of a line for the 2 points 0, 2 and 1, 5. Boy, that was a lot of work for just one question. But I have one more just in case you didn't get it.